Okay, MAC 248 production procedures, Thursday class on the 12th of February. I went over today, once again, the stuff about the widespread panic that happened after their party. When they first get their first successes, they notice, or Stacy believes, that the bottlenecks have spread in the plant. And everybody panics. Rogo panics, Stacy panics, even Jonah says this is interesting and flies in to see what's going on. All right, so I titled this talk Root Cause Analysis because that's what Stacy does. Stacy does a root cause analysis and determines that because they are releasing materials faster than the bottlenecks can process it, materials are piling up all over the plant in non-bottleneck machining areas. The one that they cite most of all is a group of milling machines that they need to make green tag parts, but they push the green tag parts out of the way and make them only work on red tag parts, and then at the end of the line, there's no green tag parts to assemble everything. So their red tag, green tag system, while valid and working and making progress, needs to be fine-tuned or optimized a little bit. So how do they do that? How do they optimize that? They hear from Jonah about it, but then Mr. Rogo goes home and works with his kids and asks them for ideas on how they might solve the problem of the Boy Scouts in the hike, because that hike and Herbie, the bottleneck on the hike, are the analogy that they're using at the Barrington plant. So while the kids are thinking about how do we keep Herbie moving and in a nice, steady, smooth fashion if he's in the middle of the line, and how do we keep the Boy Scouts in front of Herbie in the middle of the line from spreading out too far? His daughter comes up with the drum analogy. And I said, behind a group of troops, it used to be, you know, a couple hundred years ago, the drummer boy kept order in the ranks so that the troops would not spread out. They would keep in the same straight line and march across the field the way that they were ordered to. The drummer boy also kept the troops from panicking and gave them something else to think about as they marched across an open field. The rope analogy was come up by his son, who says, well, hikers going up a mountain need to stay the same gap, and for safety, they tie a rope to each other. So the people in front of Herbie on the line, if they were tied to him by a rope, could not get any further than so far. Well, if you've got machines overproducing red and green tag parts, and you need to restrain them, especially after the parts get through the bottlenecks so that they all come out to assembly at the right time, how better a way than to tie a rope to them somehow? And how better a way in both of these situations to go ahead and release materials onto the floor to the beat of some drum? Well, the drum is the main bottlenecks at the heat treat and the NCX10. How long does it take from when I put the material in the front of the plant till it gets through the bottleneck? Well, they didn't know that. So they timed it, and it ended up to be 2 weeks from the front door to the bottleneck. Then, with the green tag parts, they worried about how long it took from the front door to assembly, because not all of those parts went through the bottlenecks, but you know, even the ones that did, they were tied, their release was tied to assembly, a rope. So when it was tied to getting to assembly, you don't want to release too much and overproduce at this place, because then the inventory will pile up. We had several students today make excellent points about how this idea is confusing. This is not intuitive. Or they would have figured out a long time ago on the floor that they needed to do this. No, what they were, the old ethic was and was up to this point was produce as much as you can, as efficiently as you can, every step of the way. It turns out that a plant where everybody is working all the time really is inefficient. If somebody is waiting for 10 or 20 minutes or even a half hour in front of a machine for parts, and this helps maintain a nice smooth flow through the plant, well, that's what you do. You don't go ahead and overproduce and shoot yourself in the foot by delaying parts to their final assembly. All right. So the last, that's how the drum buffer rope analogy got applied into the plant. It starts on page 216, how this gets applied to the Barrington plant. And they set up a system by the IT guy with spreadsheets. We'll say it was just spreadsheets to time release and to monitor when inventory is actually into a place. He gets good data. He even gets a tolerance of plus or minus a day for when that material will get there. That means certainty. That means value to a businessman. And that means that also that they have achieved a lot of their goals and they begin to get measurable successes. And when they report these successes to the plant, they get asked for more. So the title of the third shot talk should have been, they always want more. If you come in and make 300 parts one day, and then the next day you come in and you make 450, the day after you make 300, they're gonna come up and say, why didn't you make me 400 parts today? What is the holdup? All right, so you'd think that they'd have been extremely happy about the measurable success, but they are in such a bad shape in this company, this whole overall company, that their local success there needs to be increased, so I guess to save all of their jobs. So we learned about how a root cause analysis of a very complicated problem in flow management through the plant led to the drum buffer rope analogy, which became a system fix using computers and software to time the release of the plant, time the release of materials through the plant, through the bottlenecks and to assembly in such a way that there's a drum beat of release to the floor and a rope keeping things from being overproduced or pushed through the system too quickly. This leads to a buffer, which is critical in project management, that you manage, and so you have a time buffer for Murphy's Law and all the things that can go wrong. Please read chapter 27 very closely about the success and what goes on with politics and numbers in this meeting. And we will continue the same subject for one more class where we will say how they get their measurements. And then we'll begin to think about closing the project of reading the goal and getting the most out of it. Thank you.